Hello and welcome back to another episode of Math with Son. Today we are going to be doing free body diagrams for AP Physics 1, and it's just the introduction on where all of these things go. We're going to have examples in the next video, okay? So when an object is on an incline, the forces acting upon it are broken into different components. You are going to have your parallel and perpendicular force, okay? So for starters, we have this incline with a theta. They normally give you the angle of the incline. And then I like to do my dot here and go down. And I would like to do my over here. So this one would be the perpendicular force, which I call WT. You could also call it, not WT, W and then the perpendicular symbol. And then this one would be the force parallel. Okay? That in a nutshell is simple. You could memorize the formula from this point, but I would recommend understanding that this one, for the first time ever, W perpendicular, the vertical component, so to speak, is not what you think it is. The vertical component is not going to be sine theta. It is going to be mg, mass times gravity, cosine theta. Whereas the parallel one is going to be mg sine theta. Okay? So I'm going to take some time to explain why that is, and that sometimes gets people confused. Okay? With our free body diagram, the other thing you need to pay attention to is the force natural is going to go away from the surface. It's going to be perpendicular to the surface that it is inclined on. And gravity is this one right here. This would be force of gravity. All right, so with the force of gravity, that's mass times acceleration. That is why we got mg here, cosine theta, and mg sine theta. Let's get into the angle in y, which I got a new piece of paper for you as well. This is the main thing. This is what confused me for a while. If you have your angle here, and this is 90, if you have both of those, hopefully you know by now, geometry, that right angles and triangles and stuff, they all add to 180. So this would be 90 minus theta. Because if this is 90, and that was like 40, this would be 90 minus 40, and you get 50. More importantly than that, there are parallel transversals in play here. So I'm going to draw a parallel transversal here, parallel transversal. This angle would equal that angle. And I'm going to highlight them here as well. We have this angle will equal this angle because these guys right here and here are parallel. So I can replace this part with a 90 minus theta. And if I replace that with a 90 minus theta, we're going to have to zoom in real quick. And I look at this triangle, we got a vertical angle right here. That means that vertical angle is also 90 minus theta, and this angle at the top would be our original theta. Okay? So if I take this triangle over here, which I'm going to kind of redraw like so, this part is the vertical angle right here and here. This is where we had theta, 90 minus theta. So this would be 90 minus theta, and this would be our theta then. So essentially, this triangle kind of flip-flops, and you can think of it as this is the short side, this is the long side. Here's your short side, here's your long side for that. Now remember that this was the force of gravity. This is the force of gravity. This is the y component, and this would be the x component. And the y component, because it is opposite and adjacent, this is your opposite, this is your adjacent, which brings us all the way back to right here again. All the way back to here when we dealt with this one. Let's see if I can get both of them on the same screen. When we dealt with this one, no, I can't, probably not. Nope, not gonna happen. Maybe. Yeah, we got it. So when we dealt with this one, we had to go from this theta, which is why the opposite is relating to sine. Sine is opposite over hypotenuse. The sine gives us your parallel component, and the cosine gives you your vertical component instead of what we would typically think, where normally sine is vertical and cosine is horizontal. Not in this case. In this case, the cosine gives you what I would consider more your vertical component. At least it's vertical in relationship to the block on the ledge, this inclined plane, and the parallel is the sine. All right, those are the two main formulas that we will use in our next examples coming up. Until then, I will see y'all later. Bye.